If you've been following along in this series, we're finally going to make our first deployment in our Kamal review app workflow. In this series, we're going through the process of using Kamal to recreate a workflow similar to Heroku's review apps for web applications. The first video covered using Terraform to create the infrastructure for your apps through GitHub Actions, and part 2 discussed how to use Kamal destinations to configure deployments to different environments. These 2 videos cover the foundation for our Kamal-powered review apps. If you haven't watched them yet, I encourage you to give them a look before watching this one so you can see what we've done so far. The next step after creating new servers through GitHub Actions and configuring Kamal for the new environments in our repo is to perform deployments automatically when opening or updating a pull request. Here is where everything begins to come together to have a usable system using your own infrastructure that you and your team can use to validate new functionality or verify bug fixes before merging into your main branch. Let's see how it's done. In its current state, the Team App application used for this series has a GitHub Actions workflow file, and it's currently set up to provision the infrastructure for review apps when opening or updating a pull request. I covered the details for setting up the workflow in part 1 of this video series. I'll add a new job to that workflow called Deploy to handle the deployments using the new destination set up with Kamal, which I did in part 2. And to use the runs on setting to have it run on the Ubuntu latest hosted runner as we do with the provision job. I'll also need to use the needs setting to indicate that it requires the provision job to finish successfully before attempting to run the deployment and ensure that the servers have been provisioned on our cloud service. Next, I'll begin setting up the environment variables needed for the deployment to complete successfully under the env key. For this step, we'll need all the environment variables we've configured for Kamal in the configuration file and secrets set up for the review destination we'll use for deployments. I've set most of the values of these environment variables as secrets in the GitHub repository and will reference them here. A quick side note, you might notice that I've appended review app to the name I set in the GitHub repository secrets, and this is mostly to help me quickly view which secrets are used for review app deployments. You can name your secrets anything you prefer as long as they're set up correctly in the workflow YAML file. Just wanted to give that tip since it helps me manage these secrets easier. The deploy job now has the environment variables it needs with the exception of the review app IP and the review app host variables. I can't set these as a secret in the GitHub repository because these are dynamically generated when provisioning the server using Terraform. So how can we retrieve this information for the deployment? In this scenario, we'll need to do 2 things. First, we'll need to output the server's IP address using Terraform, and then we'll need to pass the value of the output from the provision job to the new deploy job. The Terraform script set up for this workflow in part 1 already outputs the provisioned server's IPv4 address, so we don't need to modify it. So that leaves us with passing that value over between jobs. GitHub Actions jobs are isolated from each other, so we can't get this information directly from the provision job. However, we can output data from one job to make it available to a dependent job in the form of a key value pair. We've set up the deploy job to depend on the provision job using the needs setting, so we can pass the data we need between them. First, I'll need to update the provision job to include a step that will use Terraform's output to retrieve this new server's IP address and store it somewhere. Under the provision job, I'll add a new step under the steps key to do this. I'll set up a name for the step called setup Terraform outputs, and I'll also give it an ID to reference this step, which is necessary as I'll show later on. I'll set the ID for this step as Terraform outputs. Finally, I'll run a command and I'll do it on a new line using the pipe character. And here I'll use the echo command to print a string containing a key value pair as mentioned earlier that will serve as our output. The key for the output I want to use will be called review app IP. And I'll assign it a value using the equal sign. I'll need to get the IPv4 address from Terraform's output. So I'll perform a substitution using the $ and the parentheses to run the command Terraform output with the raw flag and the name of the output, which is IPv4 address. It's important to use a raw flag here so we can get only the value of the output. Without this flag, Terraform will print out the name of the output as well, which we don't want here. We only want the IPv4 address. With our key value string prepared, I'll append this string using the append operator to an environment variable called GitHub output. GitHub output is a special environment variable in GitHub Actions that allows us to set up data to reuse in other steps for a job. I can use this data in the provision job in other steps as needed, but as mentioned earlier, jobs in GitHub Actions can't communicate between each other. So I'll need to find some way to make the IP address I stored in GitHub output available to the deploy job. We can do this by using the output settings in the job. So under provision, I'll add a new setting called outputs, which lets us make data available to dependent jobs. I'll set the key using the same name of review app IP as I use when passing the data to GitHub output, and I'll need to retrieve that value that I set in the key value pair for the environment variable. Retrieving a value from GitHub output starts with the $ and curly braces with the format of steps, followed by the ID of the step where we set up the output, which is Terraform outputs. So that's why we had to add the ID to the step, followed by outputs. And finally, the name of the key that we used in the string append to GitHub output, which was review app IP. So this will set up the value of that output, which is the new server's IPv4 address, and allow us to use it in the deploy job. So now I'll go back to the deploy job, and in the environment variables, I can retrieve the value of the output I set up in the provision job by once again using the $ and the curly braces, starting with needs, followed by the job identifier, which is provision, then outputs, and finally grabbing the name of the output key that we want from the provision job, which is review app IP. Just as a reminder, you could only pass data between jobs this way when the job that's fetching the data, in our case the deploy job, depends on the one providing the data via the need setting, which in our case we set it up to need from the provision job. This is an easy step to miss, so make sure to remember that when using outputs between jobs. I'll set the same IP address as the host for now, even though this is going to change in the future. With our environment variable set up, I can proceed to set up the steps for deploying the application to the new server using Kamal. The deployment job will consist of a few steps to set up the GitHub hosted runner. First, we'll start by checking out the code from my repo into the runner using the actions checkout action. So I'll call this step as checkout repository, and it uses the actions / checkout action, and we'll use the latest version, which as of the time of this recording is version 4. Next, I'll use the setup Ruby action to install Ruby and all gem dependencies for the application. I'll call this step setup Ruby, and it uses the Ruby / setup Ruby action, which is at version 1 as of today. I'll also use the with key to configure it to cache the bundler dependencies using bundler cache and set the value to true. While I don't need to set up Ruby for this step, the reason I'm doing it is because I have Kamal already set up as part of my application's dependencies, and I want to make sure that I use the same version of Kamal defined in my gem file. You can install Kamal separately here or run it through Docker as an alternative, but I would recommend always using the same version of Kamal that you use when deploying your apps to production so you can avoid any surprises during the testing phase. The next step we'll set here is very important for deploying to our server. Kamal uses SSH to connect to the servers it'll deploy to and run the various commands it needs to get the application up and running. The server we spin up in this GitHub Actions workflow will automatically have a public SSH key we set up for this purpose, as configured in my Hetzner Cloud project and set up using Terraform. However, the runner used for the deploy job won't have its corresponding private SSH key, so it's up to us to get that set up in the runner. Getting this set up from scratch is a bit of a pain, but thankfully there's an action that helps us get this step working easily without all those complexities. So let's see how to get that working. I'll create a new step and call it configure SSH key. And this step uses an action called web factory /SSH agent and its latest version, which is version 0.9.0. And this action will take care of setting up everything related to SSH under the hood. And in most cases, we only need to supply it with a private SSH key. But before we get this step to work, we'll also need to handle some prerequisites. While you can use your personal SSH key for setting up this workflow, I highly recommend to create a separate key when setting it up on GitHub like this. It'll help keep your system secure in case the key is ever compromised, and it'll make it a lot easier to control which repositories have access using that specific key without exposing other repos or other systems that you have under your control. I already have a separate key set up for this, so I won't show you how to do it, but if you want to learn how to generate a new SSH key, check out the Generating a New SSH Key section in GitHub's documentation, and make sure you save the key in a different file besides the default location so you don't accidentally overwrite any existing keys in your system. When you have the public and private SSH key pair that you want to use for the review app deployments, you'll need to set them up both in the GitHub repo and in the GitHub Actions workflow. First, you need to set up the public SSH key in the GitHub repository so GitHub Actions can use it to perform deployments. Setting up the public SSH key in a repository can be done by going to the settings section in the repo on GitHub, going to deploy keys, and adding a new deploy key. Just give it a title, something like Team App Review App Deploys, and paste the value of your public SSH key as the deploy key's value. And it doesn't really need write access, so you can leave this unchecked and just add the key. Configuring a deploy key on a repo attaches a public key to it, but we also need to set the private SSH key on the server that'll perform the Kamal deployments. The secure way to handle this is to create a new repository secret that contains the value of the private SSH key. We can then refer to the SSH key without exposing its contents throughout the workflow process. I'll create a new secret in my repo and call it review app SSH private key. And for the value, I'll copy the entire private SSH key here. The private SSH key should start with a line similar to begin private key, so make sure that you're using the private SSH key here and not the public one. Otherwise, the workflow won't be able to deploy using Kamal. Once you set up the public SSH key as a deploy key on GitHub and add the private key as a secret on your repository, we can then configure this action using the with setting again and set the SSH private key setting using the secret that you just added. So in our case, it'll be secrets.review app SSH private key. With this configuration, the GitHub hosted runner is now ready to use Kamal for deploying the application to the provisioned server. We'll add 2 conditional steps to this job to check if the workflow is triggered by a newly opened or reopened pull request so we can run the initial Kamal setup command for the review destination, or if it's triggered when updating the pull request branch so we can run a regular deployment. So why do we need to have 2 distinct steps handling the deployment conditionally? The issue is that Kamal currently requires us to explicitly use the Kamal setup command for the first deployment so it can install Docker if it's not on the server, set up the accessories and the proxy service, and get the network working for our app. This step isn't idempotent, meaning that if we attempt to rerun Kamal setup, the command will fail. Once we set up the server with Kamal, all subsequent updates need the Kamal deploy command. As a first pass to get our review app workflow running here, I'll create two separate steps to distinguish when we need to run Kamal for the first time or if it needs to do a regular deployment to update our application. I'll create a new step and call it Kamal setup, and I'll make it run conditionally using a if statement here and checking if the github.event.action equals opened, meaning that it's a newly opened pull request, or if the GitHub event action equals reopened, which means that it's a reopened pull request. If any of these two events happen, then I'll want to run the Kamal setup command. So I'll run it with bundle exec Kamal setup, and remember to set the destination using the D flag and the destination name, which is review. I'll create a similar step called Kamal deploy and also add a similar condition to check the GitHub event action, but this time we're going to check if the action is synchronized, which means that the pull requests branch received an update. If this is the case, we'll run the bundle exec Kamal deploy command and once again set the destination using the D flag. Having these two steps will help determine whether to run the initial setup or a normal deploy. However, setting up steps like this isn't really ideal and it could fail pretty easily. So for example, if we open a new pull request and for whatever reason the deployment fails, we'll need to rerun the Kamal setup command again if we want our application to work on the new review server. But the problem is that the only way it'll happen with this workflow is if the pull request is open or reopened. So that means we can't push a fix to the branch since it'll trigger the Kamal deploy command instead, which will fail since the server isn't set up properly. So the only way around the problem is to either manually complete the Kamal setup yourself or to close and reopen the pull request so it can delete the server with the incomplete setup and create a brand new one. Unfortunately, Kamal doesn't offer a simple way as of this video to know if the Kamal setup command was successful or not. So this is my way of working around that limitation right now. I'll explore a few different ways to work around this issue in a future video, so make sure to subscribe to this channel if you want to see what different ways we have to actually accomplish this a lot better. But for now, we'll go with these steps instead, knowing the potential pitfalls just to get this workflow up and running. So everything is now set up for GitHub Actions to deploy our app to a fresh new server on the cloud. So let's take it for a spin. I committed the new workflow to a branch in my repo and have a new pull request ready to go. So once I create this pull request, it should trigger the workflow, provision the new server, and commit the deploy to the server using Kamal. So let's see if it works. After opening the pull request, GitHub Actions will trigger the workflows I set up for the repo, including the review app workflow. It'll first run the provision job to spin up the new server on Hetzner Cloud, as we showed before. And the only thing that really changed here is configuring it to store the new server's IP address as an output, so everything should work as it did before when I showed it in part 1. After deploying the new server, the workflow is going to kick off the new deploy job and go through each of its steps after setting up the environment variables from the repository secrets and output from the first job. It'll set up Ruby and install the gems to make sure we have Kamal available, configure the SSH key on the runner, and run the Kamal setup step. It'll also skip the Kamal deploy step since this is a newly opened pull request. If everything is set up properly, the app will be up and running in a few minutes on the server. The initial Kamal setup was successful, but let's double check that the Kamal deploy step also works when updating the pull request branch. I made a small change in the branch and already committed the change, so I'll push the commit on GitHub and check to see if the commit triggered the workflow. So as expected, the commit triggered the workflow again on GitHub Actions, and it'll go through the provisioning step pretty quickly since the server is already set up. And when it gets to the deploy job, we'll see that it skipped the Kamal setup step and ran the Kamal deploy step instead to update the review app on the server. The work done in the previous parts of this video series to spin up new servers and configure Kamal to split up the deployment settings for review apps finally got put to work. We now have fully automated deployments to newly provisioned infrastructure by simply opening or updating a pull request on GitHub. This step replicates what Heroku and other services do under the hood, with the benefit of giving you full control of the underlying systems and deployment process. Although we have functional deployments, our review app workflow is not quite there yet. Since the process spins up new servers on demand, we won't know where the app is deployed unless we skim through the GitHub Actions workflow logs to find the IP address. Doing this is a bit of a time waster, so in the next video, I'll show you how to create unique URLs for your review apps and make them easily accessible. Make sure to subscribe to this channel to see how it's done, and to watch more videos that help developers ship their code confidently, from development to deployment. You can also check my website for a written version of this video, along with more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.